Okay, so for this stuff, what you need to do is look for something that you can replace these, I guess, these exponents with a variable or a number. So for example, I see this is base 3 and this exponent x here. So I'll let that equal, I don't know, some variable, let's say p. So now if we go through this, this guy here, 3 to the 2x, that's like saying, you know, you could sort of say, you could see it like this, right? This means the same thing. Let me know if you don't know why that means the same thing, and I can explain it. Here we already have a 3 to the x plus 36 equals 0. So now you can see that we have p squared minus 13p plus 36 equals 0. And this is just grade 10 solving quadratics. So what you have to do is think of, you know, two numbers that multiply to give you 36, and those exact same two numbers have to add to give you negative 13. So when you play around with that for a little bit, you realize that the numbers are, let's see, negative 4, negative 9. So negative 4, negative 9. Multiply to be positive 36 and also add to be negative 13. So now over here, we go back and we factor it out. So it's p minus 4 times p minus 9. This is just factoring quadratics. If you need help with that, let me know. I can show you how that works. Equals 0. And so now we have two things that multiply to give you 0. So we just, what happens here, you say, well, that means p minus 4 equals 0, or p minus 9 equals 0, and you solve for each. So in this case, bring the negative 4 over, so p equals 4 is one possible solution, or p equals 9 is another solution. But we got to remember that we let p is 3 to the exponent 6, so we rewrite this. So it's 3 to exponent x equals 4, and this is 3 to the exponent x equals 9. I'll start with this one over here because it's a little bit easier. If you write it with the same base, you can easily see here. Sorry, we'll go back. Because that's the same base, you can say that x equals 2, so that's one possible solution. And you just want to verify it quickly. So if you put 2 up in here, you know, that'll be a positive number. That'll be a positive number. So that should work out. I'm looking for anything that might result in negatives. So I know this will work out. If I plug that into the original equation, it should be 0. This one's a little bit messier, right? Because it's a base 4, so you can't really do 3 to the exponent something gives you 4. So this is where you kind of use your logarithmic rules. So what we can do is take the logs of both sides. So this is, take the logs of both sides. I get something that looks like this. And now your log rules, and just on the side here, your teacher would have given you some logarithmic rules. So for example, log of a to the x is equivalent of saying x log a, right? So it's basically this little guy over here can be up there, or, sorry, hold on a sec. This guy can be up here or can be in the front, right? So that means the same thing. So we're going to use that log rule and rewrite this as x log 3 equals log 4. Right, and then what you can do is you see these as kind of multiplied, right? So that's kind of multiplied by that. So this is where we use just our general, you know, if I had 2x equals 8, right? That's the same as I could divide both sides by 2, right? And then I get x equals 8 over 2. It's the same kind of idea with what we're doing here. Sorry. It's the same idea with what we're doing here. We're going to divide both sides by log of 3. So then what you end up getting, if I divide this side by log of 3, divide this side by log of 4, then what you end up getting is, this is just x on this side, and this side is log of 4. Sorry, That should have been a 3. Log of 4 over log of 3. And there's your other solution for the other side. And that should be a positive number if you do that on a calculator, which means that should work as well if you plug it into the top. So there you have it.